New observatories are being constructed. To be launched in the coming year, the James Webb Telescope will orbit at Earth's L2 Lagrange point 1.5 million miles from Earth, away from the Sun. Its low-temperature sensors will be shielded from the Sun, Earth and Moon. There are also 3 new ground-based observatories underway. A multinational project being built in Hawaii, the 30-meter telescope, or TMT, will use 492 hexagonal elements, each about 1.44 meters, to construct the single primary mirror of 30 meters diameter. The secondary mirror will be 3.1 meters in diameter. The largest of all will be Europe's Extremely Large Telescope, or ELT. The primary mirror consists of 798 segments, each 1.4 meters wide, but only 50 millimeters thick, with a light collecting area of 978 square meters. The optical design calls for an immense secondary mirror, 4 meters in diameter, bigger than the primary mirrors of any of ESO's telescopes at La Silla. Then there is the giant Magellan telescope, currently under construction in the Chilean Andes, which will be ready by 2022. It consists of 7 8.4 meter diameter mirrors, making a total effective aperture of 24.5 meters. Housed in a rotating 22-story high building, it will produce images 10 times sharper than Hubble, with a total collection area of 368 square meters.
This is a project that we began in 2003. It was a small group of U.S. institutions and has now grown to an international project that includes Australia, Korea, Chile, and most recently, Brazil. The next steps as we launch construction of this telescope are to build the mount, the steel mount that will hold the mirrors for the telescope, to build the enclosure, which is a 22-story building that has to rotate to allow you to move to different parts of the sky as you're looking out with the telescope.
It's a new epoch in the field of astronomy. It's a new epoch for cosmology, astrophysics, and the history of the universe. And so we'll be able to see things further and fainter than anyone has ever seen before.
It just takes us to that next level of technical capability, and these technical leaps are what enable new discoveries.
The first 4 giant mirrors for Magellan have been manufactured. Number 5 is underway, as is construction at the site in the Chilean Andes.
GMT is really an exciting thing because we know that over the last 400 years that telescopes have gotten bigger, and that has allowed us to see things with better detail and to see fainter things and to figure out what the history of the universe has been. Our technology for doing this is getting better and better. We're able to build big mirrors, and we know how to do this. We know how to build GMT. We know how to build its individual mirrors and put them together. We know that when you build a telescope view, and the GMT will have a view that is 10 times sharper than the Hubble Space Telescope. And when you build a telescope that collects more light, and the GMT will collect 100 times as much light as the Hubble Space Telescope does, that you are going to be able to do things that we can imagine and set out as our goals, to look at the history of the universe, how things have changed, find out more about the dark energy and the dark matter. Those are things that we know you can do. But I think the really exciting things will be things that we haven't yet thought of, that the new questions that will come. The other part that's really interesting about a big telescope on the ground is that you can change it. That is, you can change the instrument. So I think that even when we build the telescope, that won't be its final form. Those instruments will eventually be replaced by better ones that use the technology that's developed over the period from now to then. We know that the universe has changed from a very homogeneous kind of goo at the time of the Big Bang into a highly differentiated world where there are planets, stars, galaxies, clusters of galaxies. The universe has gotten kind of interesting and complicated through the action of gravity over time. We'd like to see how that works. And by looking at what happened long ago, which means looking at very distant, very faint galaxies, and looking in detail, which means having the resolution to kind of really see what's going on.
No doubt revealing cosmic collisions far back in time and space.